Good day and welcome to my video lectures about physics. In this video lecture, I will discuss about formula derivation for projectile motion. So let's start. There are three types of trajectory shapes that you need to be familiar with. The first type of shape is like this, wherein the ball is being kicked up horizontally and initially it is moving in the x direction and, and then projectile pulled down, and so the path that the ball travels is known as trajectory. So what equations do we need in this situation? The first equation that you need is the equation to solve for h, and this is h is equal to 1/2 times the acceleration times t squared, where h represents the height of the cliff or building, and t is the times it takes to hit the ground. This equation comes from this equation. D is equal to B initial times t plus 1/2 at squared. In this type of equation, you need to know what direction you are dealing. Is it in the x direction or in the y direction? In this type of trajectory, we are going to apply this equation along the y direction. So to show that the equation is dealing with y direction, this is the equation where dy, which is basically the height, is the displacement in the y direction. By initial is 0 because it is moving from horizontally. So h will become equal to 1/2 at squared. Another equation that you need to know is the equation to solve for the range. The range is the distance between the initial positions of the object and the point in the ground where it is landed. We know that d is equal to b times t. Now if we apply this formula in the x direction, this will become t is equal to dx is equal to bx times t, where dx is the displacement in the x direction, and bx is the initial speed in the x direction. Now we will call the displacement in the x direction as the range. So the equation will become r is equal to bxt. So these are the two equations that you will need for this type of trajectory. Sometimes in this type of projectile motion, you will need to solve for the final speed or final velocity, which is the speed of the object before it reaches the ground. And the equation you need is by final is equal to by initial plus ayt, where ay is equal to negative 9.8. Now the second type of trajectory is like this. The ball is kicked off the ground at certain angle. It goes up and then it goes down. So the ball has angle theta and it has initial speed b. This is not the bx or by. B is the vector quantity. So the vector diagram will look like this, with an x component and y component. The x component is bx and the y component is by, where bx is equal to b cosine theta and by is equal to b sine theta. Now let's assign point A, point B, and point C. What is the equation that we need to calculate the time it takes from point A to point B or to reach the maximum height at point B? To derive that equation, we need to start with this. Byf is equal to by0 plus ayt. At position B, by is equal to 0. So point B is the final position and A is the initial position. So by final is 0. Substituting each equivalent, the equation for time t is, you will notice that the numerator is negative, but when you put the value of g, which is negative 9.8, therefore the final equation is positive. So that is the time it takes from A to B. Now how about the time it takes from point A to point C? You will notice in the figure that the time from A to C is 2 times the time from A to B. Therefore, the time it takes from point A to point C is T A to C is equal to 2B sine theta over G. Now let's talk about some other equations that relate to this type of trajectory. How can we derive the equation to calculate the maximum height between point A and point B that the object can reach? So going from A to B, let's use this equation. By final square is 0 and by is b sine theta. Ay is g and dy is h. So the equation will become, therefore the maximum height that the object can reach is h is equal to b sine theta square over 2g. Now how can we derive the equation to calculate the range? Which is the displacement from A to C. We said that the range is R is equal to Bx times T, where Bx is equal to B cosine theta. So the equation will become R is equal to B cosine theta times T. And what is T? T is the time from A to C, which we already determined. So the equation will become R is equal to B squared times 2 sine theta cosine theta over G. Using the double angle formula in trigonometry, wherein 2 sine theta cosine theta is equal to sine 2 theta. Therefore, the range is equal to B squared sine 2 theta over G. Now, the third type of trajectory is like this. A ball is being launched at an angle from some elevated position above ground level. So it is going up and then going down. So h is the height of the cliff and r is the range. The usual question when you have this type of trajectory is how much is the time it takes to hit the ground, which is from position A to position C. To go from A to B, notice that it is the same as this. So we can use the equation that we use in that trajectory. The time it takes from A to B is T A to B is equal to B sine theta over G. Typically, in this problem, the velocity B of the ball is given and also the angle is given. Now, how can we find the time it takes to go from B to C? Well, in order to do that, you need to find the height between position A and position B. As already determined earlier, the height is h, which is equal to B sine theta squared over 2g. Once you get that height, then the total height, we will call it y, and this total height y, which is the height from B to C, will be used to find a time. In our previous slide, you have seen this. H is equal to 1/2 AT squared. That equation will be used also to find the total height y. So solving for t, which is the time from B to C, then the equation will become t from B to C is equal to square root of 2y over g. So the total time from position A to C is equal to B sine theta over g plus square root of 2y over g. Now, how can we find the range? What equation do we use? To find the range R, use this equation. Keep in mind that Bx is equal to B cosine theta. Therefore, the range is R is equal to B cosine theta times t. Sometimes in this type of trajectory, it is needed to find the speed of the ball before it will hit the ground. We already know that the x component of velocity Bx is constant. I have mentioned earlier in this video, we need to find the vertical velocity as well using this equation. And we know By initial is equal to B sine theta, where B is the initial velocity at point A. Therefore, By final will become B sine theta plus Gt. Once we know Bx and By, we can find the final speed. B is equal to square root of Bx squared plus By squared.